Welcome to solverfy.
Is to draw all of the non-cyclical structural isomers of C5H10. And just looking at that 1:2 ratio between the carbons and hydrogens, that tells me that the isomers that I'm going to draw are going to be alkenes, meaning they're going to have a double bond in them. So to draw my first one, I'm just going to put my double bond off of the first carbon. And then just to check, 5 carbons, appropriate numbers of hydrogens. And for the second one, I'm just going to move the location of the double bond from between the first and second to between the second and third. So I'll put my double bond here. And that's the last isomer I can draw while still having that continuous chain of 5 carbons. Because even if I were to move this double bond over here, that would change the numbering scheme on my carbons, and I would still end up having a double bond between the second and third carbons. It wouldn't change anything. So what I'm going to do for my next isomer is I'm actually going to pull one of these carbons down into a methyl group, and then I'm just going to draw all of the different combinations of double bond placement as well as methyl group placement. So for the first, I'm going to put my double bond off of the first carbon, my methyl group here, 2, 3, 4, 5. For my fourth isomer, I'm going to put my methyl group off of the second carbon and my double bond off of the same carbon. And then for my last isomer, I'm going to put my methyl group and my double bond essentially as far apart as I can. And that is the last structural isomer I can draw. There are no more combinations of methyl group or double bond placement, and there are no other carbons that I can pull down out of that continuous chain without making an entirely different substance.